The space between the spheres is inflated with air. What is the volume of the inflated space? The problem is talking about the sphering ball shown here in the picture. The sphering ball consists of an outer sphere and an inner sphere. The inner sphere is where a person rides, and the space between the inner sphere and the outer sphere is inflated with air, and we need to find the volume of that air. We're given the diameters of each sphere in the picture, so what we can do is use those diameters to find the volumes of the spheres and then find the difference of the volumes. Let's start by finding the volume of the outer sphere, and we can use the formula given here in the problem for the volume of a sphere. In the formula, V equals 4/3 pi times r to the third power. R represents the radius of the sphere. So the radius of a sphere with a diameter of 3 meters is 1 5/10 meters. So we can substitute 1 5/10 for r. And now, by order of operations, the first thing we should do is evaluate 1 5/10 to the third power. So multiply 1 5/10 times 1 5/10 times 1 5/10, and you get 3 375 thousandths. Now we're left with an expression that only has division and multiplication, so we can multiply and divide from left to right. We'll substitute 3 1400ths for pi, so our answer will be approximate. And using a calculator, we can find 4 divided by 3 times 3 1400ths times 3 375 thousandths, and the answer is 14 1300ths. Now, because we're finding the volume, we should put the units here. What units do we use? Well, the diameter was given in meters. Seeing this as a volume, we should have cubic meters. So the outer sphere has a volume of about 14 1300ths cubic meters. Now let's find the volume of the inner sphere. Try finding the volume of the inner sphere yourself. Here's what you should have. When you substitute for the radius should be half of 2 2/10 meters, so it should be 1 1/10 meter. Then you should evaluate 1 1/10 to the third power, and you'll get 1 331 thousandths. Now you can evaluate 4/3 pi times 1 331 thousandths, and when you substitute 3 1400ths for pi, your answer will be approximate, and you get 5 57 hundredths. Because the diameter was given in meters, the volume should be in cubic meters. So the inner sphere has a volume of 5 57 hundredths cubic meters, and the volume of the inflated space is the difference of these two volumes. So the volume of the inflated space is about 14 1300ths minus 5 57 hundredths equals 8 56 hundredths cubic meters. That's the answer to the problem.